Hello students, today we are going to start practicals and today our first practical we are going to start from spring constant. So I will be sharing this link to you. This is a simulation link by phet Colorado. Here you can see the link, and I will be sharing this link in the description box below so that you can access directly this page. You don't have to search anywhere. We will divide this experiment into two different parts. First of all, we have to find out the spring constant of a spring, and then you can use the spring constant to determine the acceleration due to gravity. So you can see this page when you will go to this link. First of all, we have to determine the spring constant, and we will go to this lab. So I will click on the lab so that you will get this type of interface. You can see here the hanged spring. We have to attach the masses here. So when you will go to here, it will get connected. Now you can see the spring is oscillating. Okay, so now what we have to do, we have to find out the time period of the oscillation. So you can here change the mass, and then suppose now it is 100, let's take it is 50. Now you can see the oscillation period has changed. If I take it 80, 100, so you can notice that the oscillation period is changing. For a larger mass, the oscillation period seems to be different than the lower masses. So what we have to do, we have to find out the period. So I will click here for period trace so that you can notice when the oscillation has started and when one oscillation has ended. You can take the timer in this default simulation, and at a certain time when the oscillation is started, you can start the timer so that you can measure the time period. One can measure the trace from the center of oscillation or amplitude. So it will be easier to find from the maximum amplitude. So in that case you will not need this. So you can just take one movable line and place it here. Error can be occurred when we tap the timer button, so that we will measure number of oscillations. Suppose we take 10 oscillation, we will divide the time period by 10. Suppose we take 20 oscillation, we will divide the period by 20. So at a certain position, I will start the timer. Start. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have stopped the timer after 10 oscillation. So that you can note the time period for 10 oscillation, and then you can find out the time period for one oscillation. You have to note down for each mass what is the time period. So you will note down in observation table, you will note down the mass, the time period. In the observation table, you will first have mass, then you will have time period, and then you have to find out the time squared. Why this we have to calculate? Because we have to draw the graph of m versus t square, and we have to find the slope of the graph m versus t square. So you can note that the graph is almost straight line. As we are using the simulator, it will be perfect straight line. So you will get such type of graph, and then you have to find out the slope of this graph. Why we have to do this? You know, the time period of the spring oscillation is given by 2.2 under root m by k, where m is mass attached to the spring and k is a spring constant. So after rearrangement, we will get this equation: k is equal to 4 pi square into m by t square. So we will plot m by t square graph and calculate the slope, and we will put the slope in this equation. So we can write k is equal to 4 pi square into slope, and you will get the spring constant. After this, we will move to the second part. In the second part, we have to go to the stretch button. So you can go here and the stretch button. So you can see there are two different springs, but what you have to do is whatever the spring strength you have taken here, you can use only that spring strength here. You can either use strength 1 or strength 2. Okay, so anywhere, suppose I am using this, I can attach different masses here, you can see here, but in this case the springs are not oscillating. You can attach different masses. Okay, so in this case what we have to do, we have to measure the displacement or the extension the spring can make after attaching the masses. So to measure this, we will check this checkbox on stretched length and resting position. So if I am not using this, we can ignore this spring. So what we will do, we can take this scale used in this simulation and measure the length for different mass attachment. Suppose this is 250. Okay, so now the resting position will be different, right? So we have to measure this difference. Again, we have to make the observation table. You can write here mass, then the extension you can write as x, and then you have to just plot the m versus x graph or you can measure f versus kx graph. So in the observation table you can use k into x. Okay, so why k into x? So I will tell the theory. So you can plot here k versus x graph. You know f is equal to kx for the spring. So this must be equal to the weight attached to it, that is m into g. So this will actually give us the acceleration due to gravity. So in this case, m is along the y-axis and kx is along the x-axis. So we will get the slope is equal to m upon kx. This will be the slope, and this is exactly equal to, from this equation you can get this is equal to 1 upon g. So whatever slope you will get here, you have to take its reciprocal so that you can find out the acceleration due to gravity. You can either use kx or just x, but in that case this will be equal to k into g, and you can use the k from the slope of the previous graph and put it here. So you can either multiply here k for each x and then plot here, or you can just simply plot m versus x graph and then put k here. So that will be easier. So you can do. So I will erase here. So this is mx is equal to slope, that is k upon g. This will be the slope. From this equation you can find out g as k upon slope. Your result will include first the spring constant, the spring you used, and then the acceleration due to gravity using that spring constant. In your mobiles you can see the website as like this. Now what you can do here, you can check the checkbox here desktop side, so that you can find it easy to do the experiment. So I will rotate the screen so that I can see easily. Now as similar to the previous case, I will go to the lab and then I will perform the experiment here. But in this case you have to just measure the time, and then you can see here on the bottom line you can change your part from this. So you can directly jump to the second part in the stretch, and you can attach the mass here to the spring, and the unstretched length and resting position you can take, and you can move the scale here and you can measure here. The direct reading here will be the your stretched length or the extension of the spring, and you can use this to plot the graph. Check that the string length you used here and the string length you used in the first part here, it should be the same.